Hello and welcome to another lesson with Professor Checo. This class is pre-calculus for business. So we are up to lesson 3.4, present value of annuity and amortization. So let's go ahead, take a preview at this. All right, and it seems we have 22 questions. So let's get started. Let me just, I need a new tab, open that up, there we go. And I'm definitely gonna need Desmos. And now that I have Desmos, let's bring this over here and bring that over there. All right, here we go. Question 1, let's take a look at the textbook and see the critical information that we're going to need. (3.4) Present value of an annuity. So looks like that we know this equation. Let's see. They're just working. So here's the present value of an ordinary annuity. PV is equal to the payment 1 minus parentheses 1 plus I raised to the negative n divided by I, where n is the number of payment periods. So I'm guessing that's going to give us to work backwards. Let's take a peek. Present value, yep, okay. Future payment, present value. Moving on. Anything? Nope. It looks like it's just going to be a lot of equations so far. Constructing an amortization schedule. That's going to be with mortgages and how much left. Yeah, so this would be like your payments, the interest rate, money going towards interest, unpaid balance reduction, unpaid balance. Unfortunately, I don't know if you guys have houses or have property, but you will learn all this as you take mortgages, the amortization rates and the schedule. Okay, moving on. Calculating the present value. Moving on. All right, let's see. Summary: strategy for solving mathematics of finance problems. Determine whether the problem involves a single payment or a sequence of equal periodic payments. Simple and compound interest problems involve a single present value, and a single future value. Ordinary annuities may be concerned with the present value. Okay, step 2. If a single payment is involved, determine whether the simple or compound interest is used. If a sequence of periodic involved, determine whether. Okay. And that just kind of gives us the start. Single payment or sequence of payment. Is it single payment, simple, compound, future, present? And then these are all the equations given to that. So that's actually something really good to have. If this was me, I'd be writing it down, whatever. All right, and that's it with the textbook. Let's get straight into it. All right, so find the sum of the finite geometric series. So you are multiplying it by 1/4, obviously, because 4 is 16. I just don't know the equation. What's the equation? There it is. Now I'm going to go to Desmos. I'm going to open my calculator. I'm going to move this down just a little bit. So, well, just a little bit. Just so I could see it? Come on, just so I could see it. Oh, you're annoying. Okay. So it's going to be equal to, there's a fraction. So let's create the fraction. And then A is our first term, which is 6. Parentheses 1 minus the rate, which we know is 1/4, or the ratio, I'm sorry, raised to the n. Now this raised to the 16,384 is what root of that? So I need to find 4 to the x equals that number. 16385. 16385. And let's say y equals 0. And then what is that intersect? Oh, 7. Oh, 4 to the 7? Okay. So that means that this should be to the 7. So there are 7 terms divided by 1 minus 1/4. 1 minus 1 divided by 4. Okay. Type an integer or simplified fraction. Can I just put 8? No. 16383 divided by 2048. It starts with 6. I'm multiplying 1/4 to the 7 times. Oh, I think it's actually 8. I think there are 8 terms in this number because you have to add 1. So let's try this. So let's do 65535 divided by 8192. 8192. 65535 8192. There we go. So the reason that I messed it up because this is 7 to the 1/4 to the 0. So there are 7 numbers plus 1 gives me 8, and that's why I got the answer. Cool. All right. Find the sum of the finite number for S. So this is 1, 2, 3, 4, 5, 6, 7, 8. The only difference is the rates can be a negative, so then this will be a plus. This will be a plus. 1, 2, 3, 4, 5, 6, 7, 8 terms. It should be that number. 196611 divided by 40960. My rate is negative 1/4 times a negative 4 times a negative 4 times a negative 4 times a negative 4th. Oh, this needs to be minus, that's why. Boom, negative parentheses. Like that. And I'm going to do minus parentheses a negative that. Yeah, it was just changing my numbers ever so slightly. 39321 divided by 8192. No. 39321. The ratio, the ratio here is 1. It started with a 1. Oh my goodness. 13107 divided by 16384. I didn't realize the number changed on me. Okay. All right, find the interest. Find the I, the rate per period, and N, the number of periods of the following loan at the given annual rate. Monthly payments of $318.85 are made for 8 years to repay a loan at 8.5%. I is obviously going to be 0.0. Let's clear this up. 0.085 divided by 12, oh, not 15, divided by 12, which gives us, type it 4 decimal places. 0.1231. N is the number of payments, so that's going to be 12 times 8. 12 times 8, 96. 12 times 8, 96. All right, same exact thing here. Find the I, and then find the N. Find the I, then find the N. Same exact thing. Find the I, then find the N. Okay, solve the problem. Ooh, I don't remember the formula. It's the payment, so I'm just going to minimize this a little bit. Oh, come on. Can I zoom out a little bit? Will that fix my problem? No. You are a big boxer. Okay. Dang. That's the best I could do. It's my payment. What's my payment? $234. So my payment is $234, and then it's going to be a times a fraction. 234. 1 minus. No, let's do this. 1 minus parentheses. 1 plus I. I is going to be the rate. What's my I? I is 0.053. 0.053 raised to the negative n, raised to the negative, what's n? 30. I hit enter accidentally. 30 divided by I, which is 0.053. What's my principal value? Oh, my present value, 3477.34. I can't see it. I gotta zoom in a little bit more. Check. Cool. Control plus, control plus. There we go. Okay. All right. Was it the same exact thing? Principal value. Yep. Oh, now we have to work backwards. So what I'm going to do is I'm going to show you guys how I do this. Is if you just take your fill in everything. So that'd be 105 because this is just going to give you a number. My I is 0.12. Down here is 0.12. I have all that. That gives me that. And now if I take my my present value divided by 59.51754613. So my payment should have been $473.31. There you go. You're just kind of working backwards. So like if you're doing the midterm, you should be writing this down, right? Whether it's a screenshot, whether there is no preference but like I need to start seeing the work, guys. Oh, I'm sorry. Keep in mind that for the midterm, I'm going to need to see the work. Same thing here. So now here, n is going to be up there. We just kind of figure it out. So let's go ahead and let's just say that this equation, y equals my payment, which is $500, times what is my I? My I is 0.05. This down here is 0.05. N is equal to X, right? That's what we're trying to find. We want to know when this is equal to 17,000. Oh, no, I typed it in the wrong place. Oh my goodness. Y equals 17,123. And now let's see when that gives me that intersection. 37.3, round up, 38. Cool. There you go. So this was the midterm. I'm showing you that. Use the formula for the present value of an ordinary annuity of the annualization formula. So now we're just going to be solving for I. So honestly, this would be 50. I can make this X, and I can make this down here X. It's going to be a very small number. My payment is that. When does this equal 12,000? There we go. And now let's just zoom out. So we can find the intersection. It'd be a very small number. Very, very small decimal. Was that 0.034? 3 decimal places. 0.034. Cool. So now if this is the midterm, I'd be taking a screenshot maybe of this. This would not be uploading, right? Like you're trying to show the work, whether you're writing the equation and solving it that way, whatever. But that's what I'm showing. Explain what is meant by the present value of an ordinary annuity. It's the sum of the paid balance on annuity at a specific time and point. Maybe. It is the value. I don't know. This is a definition. No. Try again. It's the value of an. There you go. That's what it is. All right, moving on. Explain how an ordinary annuity is involved when you take out an auto loan for a bank. Oh, I have no idea. I don't know. Try again. Yeah, sure. It's a definition, guys. American General offers a 12-year annuity with a guaranteed rate of 5.19% compounded annually. How much should you pay for one of these annuities if you want to receive payments of $2,200 annually over a 12-month period? No idea. But this is why. Let's see. How much should the customer pay for this annuity? What does the given example say? We got to find the present value. Oh, that's it. Okay. So let's find the present value of it. Ooh. payments of 800. You got to find I. That's fine. And then find the number of periods earned by the number of payments. And you just plug it all in. Alright, I just need the equation then. The equation is up here. It's going to be something parentheses 1. Oh, I need a fraction. Fraction 1 minus parentheses 1 plus I raised to the negative, all divided by a number. Now we go back here. My payment is 2200. This is 0.0519 divided by 1, so it's just going to be 0.0519, 0.0519 raised to the negative 12-year period. So how much should the customer pay for this? $19,291.88. Yep, it's a big payment. All right, eLoan, an online lending service, recently offered 60-month auto loans at 5.7% compounded monthly to applicants with good credit ratings. If you have a good credit rating and can afford monthly payments of $440, how much can you borrow on that? How much can you borrow from eLoan? So we got to find the future value, right? No. Why do I want to find the present value? Oh, because I haven't. Okay. So let's do the rate is $414, which is 5.7% compounded monthly, which means that this is 0.00475, and then down here is also 0.00475, and then now I just need to know what 12 times 60 is. 720. So if I were to do 720, would this car really be an 84? Would it really cost me $84,283.57? My payment is $414. 1 minus 1 plus I. I is 0.57 divided by 12, which is 0.00475. And then N. Oh, 60 months. Oh my god. No, that's just 60. It's 60 months. Not 60 years, 60 months. So that should be there. That's much better. Alright, let's check that. Plug it in. Delete. Let's do $21,569.68. There we go. You will pay how much in interest? How do I figure that out? Oh, 414 times 60. $24,000. So it's 24840 minus 21569.68. I'm gonna pay $3,270.32 in interest. Really? I thought I had that one. Oh, 32. Didn't put 32. There we go. Beautiful. All right, if you buy a computer directly from a manufacturer for $2,692 and agree to pay it in 36 equal installments at 1.9%, how much are your monthly payments? So now I'm just looking for that number, right? So it's 36 equal payments It is 0.0198 divided by monthly, right? Per month. So that number is going to be 0.00165, 0.00165 down here. Am I missing anything? No. And then I just take the amount that I'm going to pay, 26.90 divided by these payments, 34.93, which gives me $77.01. Oh God. Where did I go wrong? Let's take copy. Let's paste that right there. 77.03. 0.02. I was way off. 36 equal payments. 1.98% divided by per month gives me that. Shit, this should have been 3. Because it's 3 years. Right? So now if I were to do 2690 divided by 2.99, no, that's way off. Still. 0.015. Where did I get this wrong? 1 minus 1 plus I raised to the negative that. Okay. Stop the first part. First use the present of an ordinary. What? Oh no, that's fine. That's fine. That's fine. That's fine. That's fine. Everything here is correct. Yeah, no, they just switched them because they divided it. I got that. I got that. Yeah. Mm-hmm. Number period is 24. So then that should have been 36. That. Negative 36. Point 0.00165. 0.00165 raised to the negative 36. That I agree with. That I agree with. How much are your monthly payments? You take the 2,690 divided by that. Gave me $77. I was off by that. I don't understand though. If you do $105 times 36, you're paying $2,700. So then you're telling me that it's minus 2690. That's crazy though. The total interest paid is 105.20. 197.2. That's crazy. It doesn't make any sense. Why would you pay $1,000 in interest? I don't know why I got that one wrong. I must have typed into the equation incorrectly. Alright, let's clear all this out. Clear this and clear that. The annual interest rate on a credit card is 15.99%. If a payment of $100 is made each month, how many months will it take to pay off an unpaid balance of that? Assume that no new purchases are made within the credit card. I'm just gonna go to I'm just plugging into that. Okay, so it's just that payment 1 minus 1 plus I. So here it's 0.1599 divided by monthly, not minus, divided by 12 gives me, that's my new interest rate, 0.013325. And then down here would also be 0.13325. And now the question is, how long will it take them to pay it off? So then that's going to be raised to negative x. Your payments are $100. So I'm going to set that equal to y equals, and let's then go ahead and say y equals $2,468.66. Go back to home, zoom out until we see this 2,000, and I'm looking for this intersection. 30.31 months. Cool. You want to purchase an automobile for $31,738. The dealer offers you 0% financing for 48 months or a $4,980 rebate. You can obtain 6% financing for 48 months at a local bank. Which option should you choose? Okay. So let's see. This is going to be just principal rate times time, right? So $31,738 PRT, right? Isn't it principal rate times time? P times I think it's 1 plus r, which should be 0 raised to the 48. No, this needs to be 6%. 0.06. Drawing a blank. Let's just look at this. So we need to find the present value. Yeah, I got that. That's the price. And then what we got divided by the number of 36. Calculate monthly payment. I got it. That makes sense. $31,738 divided by the 48 months means that I'm going to have a $661 payment. So now the question is, or you can obtain which formula do they use to find the interest on the second one? The present value, which is 31,738 times this fraction that's going to have the I up top. What's my interest rate? My interest rate is 0.06 divided by 12 because it's months. So up here, uh, 0.005. Down here it's parentheses 1 minus parentheses 1 plus 0.005 parentheses raised to the negative 48. which would then give me $745.37. Okay, now that gives me that. So what's 704? Oh, it's right up here. Times the 48 months gives me 35,777.76. But if I were to delete the rebate, that gives me $30,797, which is cheaper than the 31,000. So I'm going to take the rebate. Let me go through that one more time. We know the car cost $31,000. We found the payment that it would cost with a 6% interest rate. And then when we worked backwards, we found out that we'd be paying $35,777. Minus the rebate brings us down to $30,767. So you're obviously better off taking the rebate than you are the financing. How much money would you save per month? This minus that divided by 12. So what's 31,738 minus 30,797.76? That gives me 940.24 divided by 48, and I would save $19.59. Oh my God. How much money will you save per month? Part 2? Really? I thought I did it all right. Oh, it's right there at the end. 2, 1. That minus that. Yeah, I got that. 940. That minus that. So if I just do, where are my two loans? My one loan is 745.367 minus 661.208. How much will you save per month? That. Let's try that number. 840.15.16. No. Okay, I got confused. It's 661. 661. Are these the two differences? Oh, it's this number. Control copy. It's that number. That number. 31,738 minus that. Control V divided by 48 gives me 19.58. 19.58.59. $32.80. I was not close. Oh, that's annoying. Somewhere I made a mistake. Alright. Luckily, the view and example is there. Try to follow it along. I made a mistake somewhere. Number 17. Let's go to 18. Construct an amortization schedule for $17,000 debt that is amortized in 10 equal semi at 5%. What's the formula? This one. So it's a parentheses, a fraction, I, and then 1 minus parentheses 1 plus parentheses raised to the negative. Right? Okay. So here it's my present value of 17,000. I is going to be 0.055 divided by semi-annual is 2. So that's going to be up here, 0.0275. This is going to be plus 0.0275 raised to the 1. Hmm? Plus I. No, this is not right. Why is I equal to 0.55? Semi-annually? Why is it that? That doesn't make sense. So 0.055, that doesn't make any sense. Oh my god. Why is this so big? Why is this number so big? 1 minus 1 parentheses. Boom. Do I gotta put that in parentheses? No, that didn't do it. 0.05. This number's huge. My payment is not 17,900. Present value is 0.005 because it's a 5.5 interest rate. 1 minus 1 plus that raised to the negative 1 times the present value. There are 14 payments. Negative 4. What am I paying? 10. I had negative 1. Okay. My payment is 2255.35. I have no idea how to make an amortization schedule. Find the interest, multiply the first times that. So then if I do 17,123 times 0.055, that gives me $935. Unpaid balance reduction. Oh, that's just gonna be that minus that. 2255.35 minus 935. 1320.35. And then 17,123 minus the 2255.35. $14,744.65. I literally did. How off am I? That was right. That was right. That was right. This one was way off. Oh, it's just minus the 1320.35. 15, it's just minus the unpaid balance. Okay, I can deal with that. So here, my payment is still 2255.35. My interest is now the. Oh, I have to change all the numbers. God dang it. Hold on. Yeah, business isn't easy, guys. So let's do 15,679.65. And then everything else should be the same, except now it should be 9, right? So then this should be 2256.79. My interest should be that 15,000. This number changes. 15689.65 times that. So my interest is 862.93. My unpaid is going to be that minus that, so it's going to be 2256.79 minus 862.93, which gives me 139.86, 1393. And then I just take 15679.65 minus the amount that I just paid, 1393.86, which leaves me with a bill of 14,285.779. Dang, I thought I really had this. How off am I? Oh, it's the same payment. Oh, it's the same payment. 22535 is just the same payment, what you're going to be paying. The interest you have to recalculate. Obviously, then you have to recalculate the amount unpaid. And then obviously that would be. Okay. That was a little tricky. But that made sense, though. A family has $147,571, 30-year mortgage, and 7.5 compounded monthly. Find the monthly payment. Also, find the unpaid balance after the following period of time. So the monthly payment is going to be this number, which is $147,571 with a. Let's get rid of all this. What is my 0.075 divided by monthly, which gives me that number up there, 0.00625, and then this would be 0.0625. I did an extra one up there. And then this is 30 years, so negative 30. And that gives me a payment of 5,409.91. Oh my God. I is 0.075 divided by monthly. 1 minus 1 plus that raised to negative 30. Oh, 360. Dang, because it's 30 times 12, so that's 360. 360 payments. So it should be 1031.84. There we go. Okay, so now it's the payment calculator. So this is going to be 1031.84 times parentheses fraction 1 minus parentheses 1 plus my interest 0.00625 raised to the negative 360, all divided by 0.00625. And if we're doing Do I have the wrong formula? I have the right formula. Same exact thing. Yep. 240. I gotta multiply 120. 12 times 10 gives me 120. The unpaid balance. Do I do that minus that? I think. I don't know. What do? They find the amount after the 200. 10 years. So 86927.0.10. That doesn't seem right. Shouldn't it be 147,571 minus that number? 0.10. What's that number? 66,4,359. Oh, I gotta do point. The point right there. Decimal. No, 120,000. Why am I getting these really, really wrong? The unpaid balance. So if I were to do 1031.84 times 120, why am I really confused? That's $123,000, but the house was 124. Oh, that's where. So then, correct answer is 128. Um, 1031.84 times 20 times 30 gives me that. 309. No, 360. 371,462.4 minus 123,820.8 is 247. No, something here is so. Oh my god. Why isn't this formula working for me? Okay. It's the payments. Let's get rid of this. Delete everything. It's my payments of, what is my payments? 1,011. It's 1031.84 parentheses. View an example down to 11. It's not making sense. I wouldn't even be upset if it's not even working. wait, what? After 20 years, the unpaid balance of a loan with 120 payments remaining is the present value of that annuity and can be computed by using the formula for the present value of an ordinary annuity. In other words, the unpaid balance after 20 years is the present value of 10 years. You mean to tell me that if I would have done negative 260? Negative 26? I don't remember where it was. Control Z. It's the 10-year 20. No, because it wasn't 132,000. It was 128,000. It's still off. 7.5. 0.075 divided by 12 is 0.00625 to the negative 240. Oh, snap. There it is. And then if it was 10 years, it'd be 12. It'd be 86,927.10. Oh, now that makes sense. And then after 25 years would be the same exact thing as 5 years, right? 5 times 12 is 60, so let's go 60. So the amount unpaid is 51,494.29. Oh, man. Okay. An ordinary annuity pays 5.8% compounded monthly. A person deposits $120. This one. $120. No, a person deposits $150 for 30 years. Oh my goodness, guys. I'm just looking at this question. It just has so many steps. First, you got to find out how much money the person saved after 150 years. $150 a month for 30 years, making 5.2% interest. I'm gonna read the view an example because this is a little crazy. All right. So determine the monthly withdrawals. First, find the future value at the end of the 30 years. We plug it into there with all that information, substitute it in, and that tells us the future value. Now use the amortization formula to determine the monthly withdrawals for the next 15 years. Principal value, interest, and all that. Boom. Working backwards, you can figure out that he takes out 1,000 there. To determine the interest during the 45-year process, find the interest for the first 30 years by subtracting the amount put into the annuity from the total amount of the annuity at the end of the 30 years. The person put in 90 and the annuity of the 90. So like you would multiply the amount that you're putting in times the 30 years to figure out how much, then you compare it and subtract it and find out how much interest. The amount of annuity for it's just subtracting and find out he did that much interest. Now find the interest in the 30 years by subtracting the total amount in the start of the last 15. By subtracting the total amount in the annuity at the start of the last 15 years from the total amount of the money withdrawn within the annuity at the start is there, because is each month that times that gives us that. Oh, and then you just subtract the 2, and that gives the amount of interest that he made. So then you add the 2. All right, and then you just find out how much he made total. To find the monthly deposits required to withdraw $3,000 per month, so now you got to work backwards. So if he wants $3,000 per month, you have to first find out how much should be in the pot, and then once you have how much is in the pot, you got to figure out how much he's going to do it over the first years. Wow, that's a heck of a question. Heck of a question. Good luck. A couple wishes to borrow money using the equity in their home as collateral. A loan company will loan up to 70% of their equity to purchase their home for 11 years at that much. The home was financed by paying 50% down and 15-year mortgage at 9% on the unpaid balance. Equal monthly payments were made to amortize the loan over 15 years. The net market value of the house is now $100,000. After making their 132nd payment, they applied to the loan company maximum loan. How much to the nearest dollar will they receive? This is another ridiculous question. 23 parts. You gotta just work through it. Oh my goodness. What's this last question? Discuss the similarities and difference of the graph of unpaid balance as a function of time for 30 years. 50, 75, and 100. Respectively at 9% each one. All three graphs decrease and curve downward. The graph has the same y-intercept but different. No, has this. All three graphs decrease and go down. They have the same t graphs but different y-intercepts. The unpaid balances for each loan rapidly leading off to there. All right, so questions. That is the homework that is done. Oh, what do they want us to do? Show completed. Oh, just have to work down 30 years and work backwards for the three of them. Yep. The interest rate, find how much they pay, the interest, how much the payment, and the interest, how much they pay, and the interest. Cool. I'm going to go back and make 20 and 21 pointless. Assignment manager. Let's go to edit. These two questions are just ridiculous. So it was 20 and 21. I'm going to make worth 0 points. So if you would like to do them, by all means, must be greater than or equal to. Equation must have a value greater than or equal to 1, less than or equal to 100. Oh, dang. So you know what? I'm just going to delete these two. These two were super annoying. 20 questions for this assignment. All right. Good luck, ladies and gentlemen.